Welcome to The Explainer. Okay, today we're heading out to what honestly looks like a true astronomical crime scene. We're talking about the chaotic, super strange, and totally mesmerizing behavior of Saturn's absolute weirdest feature, the F ring. Okay, let's dive into this, because the contrast here is absolutely staggering. When we normally picture Saturn, we see this pristine, mathematically perfect system of gorgeous nested disks, right? But way out at the very edge, there's the F ring. It's this chaotic, naughty, constantly morphing wand of ice and dust. So how on Earth, or, well, how on Saturn, does a planet that's literally lighter than water hold on to something so violently complex? Now, we've all heard that classic space trivia, right? That Saturn is mostly hydrogen and helium, and its average density is so low it would literally float if you could somehow find a colossal bathtub to put it in. But what really matters for us today is the sheer scale of its gravitational web. I mean, despite that low density, its massive volume gives it incredible influence. We're talking about a planet that bosses around 274 confirmed moons and hosts the most complex ring system we've ever discovered. But we're going to skip past those smooth, famous inner rings and zoom right in on our specific target. So picture a totally smooth highway, but in one specific outer lane, all the cars are just constantly crashing, merging, and breaking apart in slow motion. That is the F-ring in a nutshell. It's a total anomaly. When the Cassini spacecraft sent back images, it showed this granular disk of ice and dust that's just incredibly naughty. It's got multiple strands, braided streamers, episodic jets, and these massive clumps of material that just seem to appear and disappear out of nowhere. Why does this one specific ring look like chaotic cosmic debris instead of a nice smooth band? Well, to figure that out, we have to interrogate the prime suspects hovering right next to it. So the crucial point is that the F ring isn't acting alone. It's basically being sandwiched and, honestly, gravitationally bullied by two tiny shepherd moons. On the inside, you've got Prometheus. This is the inner driver, and it's got the stronger gravitational pull. It strikes a gravitational beat exactly every 112 F-ring orbits, literally carving out dark channels and triggering these dense knots of material. Then on the outside, there's Pandora. It's the outer driver, providing a weaker secondary modulation. It strikes its own beat every 71 orbits, messing with the outer edge. So we have these highly specific interacting forces from Prometheus and Pandora setting the stage for our mystery. But to really grasp the chaos they're causing, we need to look at the tiny particles they're actually tugging on. The environment of the F-ring is essentially a microscopic battlefield. It sits right on a very dangerous environmental edge known as the Roche limit. Now, at this exact distance from Saturn, the massive planet's tidal forces are actively trying to rip everything apart. But at the exact same time, the tiny ice particles inside the ring have their own weak gravity, and they're desperately trying to pull each other together. So it's a delicate, continuous physical tug of war. You've got tidal disruption tearing things down, fighting against self-gravity, and collisions trying to build things up. Let's break down how this tug of war actually plays out on a micro level. Step 1 is aggregation. As those moons pass by, their gravity compresses the ring, which forces these microscopic ice particles to coagulate and stick together. Then, step 2 is where things get really wild: gravitational compression. Once a clump gets big enough, its own gravity increases, which means it starts sweeping up even more material even faster. It's nonlinear growth. It basically snowballs. But then, bam, step 3, fragmentation. Eventually, the clump just gets way too dense and it's moving way too fast. The collisions between the particles become so violent that they exceed what's known as their sticking threshold. And that massive ice clump, it forcefully smashes apart, right back into dust. Now, if Prometheus were just acting alone out there, this whole cycle would be perfectly regular. But remember those interacting forces? Because Prometheus hits every 112 orbits, and Pandora hits every 71, their orbital resonances overlap. Think of it kind of like two musicians playing slightly different notes. When their gravitational waves overlap, they create an interference pattern, a literal, physical beat. Sometimes their gravitational pulls just cancel each other out, but other times, they combine. And when they combine, they squeeze the F-ring with immense force, triggering these massive, cascading avalanches of clumping. Now, what's really interesting is that we can actually mathematically visualize this gravitational music. When we map out the time series, the spiky, jagged lines represent the mass and velocity of the ring particles as they're forced through those wild clump and bust cycles. And looking at the phase space plot, if the ring were perfectly stable, it would just be a thin, clean circle. But it's not. That thick, messy, non-elliptic loop proves that the gravitational interference from Pandora is causing intense, totally unpredictable physical modulation. The ring is literally throbbing out of phase. What researchers have actually found is that the F-ring exists right on a razor's edge of stability. Look at the math for a second. If the aggregation efficiency, which is basically just how well the ice sticks together, is at a moderate nonlinearity parameter of 1.28, the ring acts like a smooth, quasi-periodic wave. Everything stays in a nice, clean balance. But if that stickiness increases by just 1.5%, bumping up to 1.30, the entire system structurally breaks down into high nonlinearity. Suddenly you get intermittent phase shifts, broadened bands, and massive avalanche-like clumping events. Literally a tiny, tiny shift in the microphysics completely transforms the macrostructure of the whole ring. And a rotation number heat map brilliantly illustrates that exact tipping point. The smooth areas, those represent regions where the ring just hums along in a stable, quasi-periodic pattern. But notice those colorful pixelated bands cutting right through? Those are known as Arnold tongues. When the F-ring's parameters drift into those specific zones, the frequencies of Prometheus and Pandora momentarily lock into resonance together, and it is exactly in those locking zones that the chaotic eruptions and massive clumps are triggered in the ring. Which brings us to a seriously groundbreaking realization from the research. For a really long time, we honestly just thought the F-ring looked messy because it was constantly getting hit by random meteoroids, or because it was just unstructured space debris. But as the researchers clearly state, the F-ring's complex morphology can emerge from deterministic, multi-frequency dynamics rather than stochastic processes. What does that mean in plain English? It means the chaos isn't random at all. It is deeply, perfectly mathematically tuned. Let's step back and see how this builds a completely new understanding of Saturn's strangest feature. We started with what looked to all of us like a messy, dirty ring of colliding ice, but by understanding the precise orbital beats of Prometheus and Pandora and pairing those interacting forces with the microscopic rules of ice sticking and breaking, we've actually decoded the system. What appears to our telescopes as absolute, violent chaos is actually an elegant, deterministic cosmic symphony. The F-ring is simply playing the complex chord that Saturn and its shepherd moons are strumming. And that leaves us with a truly profound perspective to take away from this explainer today. We look out into the universe and, we often see violence, disorder, and random destruction. But if the messy, chaotic clumps of Saturn's F-ring are actually just part of a perfectly predictable, multi-frequency gravitational symphony, well, what other cosmic chaos is just a song we haven't learned to hear yet? Thanks so much for joining me on this deep dive. Keep looking up and always keep questioning the chaos.